Hey, I'm Sam from Prismic. I'm here today with Rich Harris. Rich, thanks for being here.
Thanks for having me.
So the big exciting thing this year is Svelte 5. And one of the biggest changes that we're talking about in Svelte 5 is the introduction of runes. So quickly, can you give us a sense of what are runes?
Yeah, runes are how you talk to the compiler in Svelte. So the background of the word rune, a rune is, in Norse mythology, it's a magical symbol that you can use to cast spells, and we're kind of using it in the same way. It's a magical symbol that you add to your code that tells the compiler that, oh, this thing here, this is a piece of reactive state, for example, and the compiler is able to take that and generate instructions in the compiled JavaScript that fulfill your wishes. And it's a little bit different from how reactivity works in some other frameworks, where either you're re-rendering everything all the time when state changes, or you're explicitly using signals with an API. In Svelte, the idea is that you're writing what feels like very idiomatic JavaScript, but you've added just this little touch of magic that makes things work reactively.
And runes are magical in that they fulfill your wishes, but they are actually fairly intuitive and easy to understand what they're doing and what you can expect will happen.
Yep.
Cool. So can you walk us through a little bit? What does a rune look like and how can we use them?
Yeah, so right now we're in the Svelte 5 preview. This is where you can go today to try Svelte 5 out without needing to download anything or install anything.
For the record, I use this all the time. I'm in this REPL like on a daily basis.
Yeah, me too, obviously. And in this code, so this is, if you visit the website, this is the example application that you see. It's a pretty uninspiring app, but it gets the point across.
Hey, we all have had a need for a button where the number goes up when you click on it at some point or another.
Right. So here we have our first rune, the state rune.
Okay.
And actually, if I get rid of this, then we're back in Svelte 4 mode. And you'll see that the icon here just went out, the runes icon. This is not in runes mode.
So does this mean that we have lost the interactivity?
It does not.
Okay.
So by going back into Svelte 4 mode, we opt back into Svelte 4 semantics. The thing continues to work. And this is really important because if you have an existing Svelte 4 app or even Svelte 3 app, and you add Svelte 5, then your existing components will continue to work. You don't need to rewrite the entire thing in order for things to work.
And for somebody who hasn't seen Svelte before, this is already quite magical. What's happening on line 2 here?
On line 2, we are declaring some local state.
Okay.
Count is just a variable, and we can add 1 to it. And anything that depends on count, which in this app is just this text inside the button, will update accordingly. And in Svelte 5, we are a little bit more explicit about that, because that idea, it feels really nice and a lot of people really love it, but you can only use it here. You can only use it at the top level of a component. You can't use it inside a function. You can't use it outside a .svelte file. And in Svelte 5, we're changing that. We're adding this concept called universal reactivity. And so the big difference is, in fact, you know what? I'm not even going to type it out. I'm just going to click the migrate button, which will take our Svelte 4 code and turn it into Svelte 5 code. You'll see that the runes icon is lit up. And the only thing that changed is we turned that 0 into $state0.
Okay.
So $state is the rune. And this is an instruction to the compiler that says this is a piece of state, and any assignments to that piece of state or modifications in the case of an object or an array should be treated as instructions to re-render.
Now, is it useful for me to ask this question? What is actually getting saved to count in this code?
Well, I can show you how the compiler is treating this.
Okay.
So this is the input. This is the code that you as the developer write. And the code that the Svelte compiler outputs looks like this. So we're turning it into a function. It's a function that takes an anchor node, where we append stuff to the DOM. And if we had props, this would be a second argument here as well. And you'll see that this code looks a lot like this. Let count equals $.source. Internally, a source is what this gets turned into on the left. And then we're creating the button from our template, which is described up here. So we can create as many of these components as we want very quickly just by cloning that template. And then we're adding the event handler. This looks a little bit funky because we're not just using add event listener. We actually do some stuff to make things more performant than it would be if you'd written it by hand. So we use a technique called event delegation here.
Cool.
Which means that when you click, the increment function gets called with that argument. And then inside the button, we have a piece of text. And then here's where the real magic happens. Inside this code here, this template effect, whenever this changes, $.getCount, we rerun this effect. And this is the heart of signal-based reactivity. We have these sources, and then we have the effects that depend on those sources. And every time the source changes, this code reruns, and we reset the text inside the button.
So, I mean, admittedly, I wouldn't call myself an expert in JavaScript. This is a little bit difficult for me to look at, but I kind of am getting the sense of what you're saying. I've heard that this code is actually more simple than Svelte 4 code.
It is. I mean, I can show you the equivalent Svelte 4 code, just to give you a sense. So previously, Svelte tried to do more work at compile time and less work at runtime. And it meant having a lot of code like this. Like we're creating a button and then we're doing some work inside that. And then we have a separate method for mounting the component and then one for updating the component and one for detaching the component. And the compiler would need to emit code like this for all of the parts of your application.
Wow.
And it's very direct. It's very immediate. Like the path between a change and a DOM update is very direct, but it means that we're generating quite a lot of code.
Okay.
And in the new world, things are a lot more simple. We're able to rely on the signal primitive to do a lot of the heavy lifting for us instead of having to emit all of this code.
Wow. So
the new world, the code that gets emitted is simpler, and the compiler itself is a lot simpler. If anyone's ever tried to contribute to the Svelte code base in the past, it's been quite intimidating, and now it's much more
awesome.
approachable.
Okay, so what can we do with runes?
So we can increment a counter inside a button, but we can also have reactive objects. So another nice example of this would be a to-do app.
Okay.
So I'll create
Classic.
some to-dos here. Yeah. Let's do let to-dos equals an array.
So we're initializing an empty array there with the state rune.
And I don't know, let's think of a to-do. So text, we're in Paris, so I don't know, visit the Eiffel Tower, can't spell. And I haven't done it yet on this trip, so that's done false. And then down here, just going to get rid of that button, we don't need that anymore. We'll have an each block, each to-dos as to-do. And then we'll add a div for each one, and then we'll have an input. And then another input, we'll make that a checkbox. Type equals checked, checkbox. Checked equals to do dot done. Okay, and I can now see that to do right there, and I have a checkbox input to mark it as done. But that doesn't actually do anything right now for two reasons. We're not displaying the done state anywhere, but we're also not responding to changes in those input elements. And we can fix both of those things. First, I'm going to get rid of this code that we no longer need. So first, I'll add a piece of derived state which tracks how many of the to-dos have been done. We can call that done. We do derived to-dos dot filter, and then get the length of that filtered array.
Okay.
And then below here, we can say done to-dos done, like that.
Okay.
And then finally, we need to respond to user interaction in these two inputs. And in a lot of frameworks, the way that you do this is by manually adding an event listener, you would do something like on change equals, and then you would get a reference to the event so that you could do to do dot done equals e dot current target dot checked, I think.
Yeah, that looks familiar.
Is that how it would work? Yeah, so that works. A little bit verbose. I don't love that personally. I prefer to let the computer do the boring work for me. So I'm just going to bind the value of checked
Nice.
to do dot done like that. And that has the same effect.
Okay, and so this, what is derived doing here?
So derived is, well, we can look at the JS output again and we can see for ourselves. It is creating another signal similar to the source, except that we can't update it directly. And every time the value of this changes, the value of done also changes. And then later when we're referencing it, we're actually doing it by unwrapping the to-do object and pulling the done property out of it. All this code gets generated for us automatically, so we don't need to think about the mechanics of it. But what's important here is that this is all super fine-grained. And I can show you what I mean by that. I'm going to turn this into a binding as well. So if I had to change some text here, then we're changing the value of the to-do, and like you could argue that we're changing the value of the to-dos array as a whole. But what we don't want to happen is to have to recalculate this when nothing has changed with the done state of these to-dos. And we certainly don't want to have to update the DOM when that changes. So we can actually add some logging here. We can see that that value has been updated, and then if I toggle this, it's going to keep updating that like so.
Yeah.
But if I change the text, nothing happens.
Look at that.
And the same is true if we add some more to do. So I'll add another input up here. And this time we'll add an event handler. And we'll say that if the key was the enter key, then we're just going to push a new item to the to-dos array.
Sure.
We'll get the current value. And we'll initialize it to false. And then as a final step, we'll clear out the current input.
Right.
Add that, and obviously that works. And we updated the number of to-dos that were done because the to-dos list itself changed. But when I change the text again, it doesn't have any effect. You can see that changing the done state updates it as we would expect.
So
I actually have it in many croissants, so I'm going to mark that one as
So it's smart enough to know which properties are changing.
Yep.
And what it needs to, what logic it needs to rerun in response to that.
And beyond that, the act of adding a new item to the array is very idiomatic. We're just using array.push. And the way that this works is by turning to-dos into a proxy. So when you call when you create some state with the state rune, if it's a primitive, then it'll just turn it into a source directly. But here, because this is an object, we need to get a little bit cleverer. So the output of this becomes $.proxy with the first value that we pass into it. And what that does is it returns a proxy object with, they're called traps. You have a get trap and a set trap. And so when you get a value, that is equivalent to calling $.get, as we saw with the primitive value earlier. And then when you call $.push, when you call array.push on the array, that is under the hood. It's incrementing the version counter of the array, and it's telling anything that depends directly on the array that it needs to update. So that's how this gets triggered. Mm-hmm. And then any properties of these objects are turned into individual sources. And in that way, we're able to get this super fine-grained reactivity without you needing to go to a lot of ceremony in order to describe that to the compiler. It does it all for you.
You said that you mentioned individual sources.
Mm-hmm.
Can you tell me what you mean by sources?
Yeah, so a source is, we'll create a count up here. Count equals .state 0. So we refer to it as state in the context of authoring, but the word that is used in the language of reactivity is a source. You have sources and you have reactions. A derived is a sort of reaction, and an effect is another kind of reaction. An effect is just some work that happens in response to a source or a derived piece of state changing.
So count is a source and done is a reaction?
Well, so right now, I misspoke because count is not yet a source. You can see over here, let count equals 0.
Okay.
Well, it hasn't done anything useful with that. And the reason is that we're not using count in a reactive context anywhere. So the compiler is smart enough to say, well, that's just 0. We don't need to do anything special here. But if I were to add that button back and add an event handler like this, then that becomes a source.
So a source means that it is. I'm sorry. What exactly does it mean that it's a source?
It's just it's a fancy word for a value, but it's a value that is aware of the things that depend on it. So every time one of those dependencies reruns, so with these template effects, for example, before we run this function, we say to Svelte, hey, this is the function that is about to run. If we call get inside this function, then just make a note of that. And so at the end of that, after the function is run, we can see all of the things that were got during the execution of that function. And if one of those things was a source, then we can say, hey, source, when you get updated, all of this stuff needs to rerun.
And those are the reactions.
Those are the reactions. Yeah, so you build up this dependency graph between the sources and the effects and the derivations in between without needing to be explicit about it. You just use the value, and using the value is enough to create that dependency graph.
And in theory, this is logic you could write yourself. The compiler is smart enough to write it intelligently, selectively for you.
Exactly. Like, you don't want to have to write this kind of stuff. You don't want to be manually manipulating the DOM. Like, if you do that, then it's really easy for subtle bugs to creep in and so on. So the idea is that you get to write this very expressive code that really cleanly expresses your intent, and then the compiler does the heavy lifting of turning that into code that will run efficiently.
So I'm writing the code that says, here's this value, and here's this other value that depends on it. And if the first value changes, the second value should change. I don't have to worry about writing all the auxiliary functions that say, like, okay, now rerun this and keep track of this. I remember when you were first previewing this, when you were first showcasing Svelte 5, arrays didn't work the same way.
They didn't.
What was the difference, and what's the improvement?
So initially, what we first shipped was basically just this. These were equivalent. If I created a piece of state like this, then mutating its properties wouldn't have any effect. Everything was atomic, and it kind of worked. Like, you could have an add to do function like this. It's kind of laborious to write out, but like, let text equals state initial, and then let done equals state false, and then you could push to the to-dos array by, well, reassigning it basically.
Right, reassigning.
So you would get the existing to-dos, and then, well, we can't just return the value here of text and done, because that just gets the current value at the moment that the function executes. So we need to instead turn this into a getter. We do get text, return text, and then set text dot value, text equals value. And this is using, the same logic that we have for count. Like, reassigning the count directly is the thing that tells it that it needs to update.
Am I crazy, or does this almost remind me of a React hook?
It's not massively dissimilar. React doesn't allow you to mutate objects. In React, if you do todos.push and then set todos, nothing will happen because they have referential identity.
Okay.
But in Svelte, by getting rid of all of this stuff and just having todos.push, we're able to have the ergonomic advantage of mutating things directly, but with the guarantees that you get from having immutable data because it's actually all backed by sources.
So what changed? How were you able to get rid of that whole getter setter syntax?
That's where the proxies come in. Initially, we were just kind of noodling around. Like when we first showed this to people, they were like, I don't know, it seems like a lot of work. It doesn't feel very Svelte-like if I need to write all of these accesses myself. And they were right. And so, we took that feedback and like, how can we do this in a way that is efficient and feels Svelte-like?
Were you worried about the effect on performance of doing something like that?
We were. And so we spent a lot of time looking at what the impact would be. And it turns out that the performance is actually perfectly fine for most situations. If you are concerned about performance and you want things to, like you really need to optimize one specific part of your application, then there is another version of this that we can use, which is classes. So we can do class to do can have the same pieces of state, text equals state, initialize the empty string, and done equals state false. And then we'll just set that to that, and then we'll turn this into a class instance. And then down here, we'll place this as well. Right, and now because we're using this custom class, which encapsulates its own state. In fact, we can get rid of. Oh no, we can't. No, we do still need that. We need to put it in array though.
Okay.
Each individual to do will no longer be turned into a proxy. It'll just stay exactly as it is, but it still works. And what's really nice about this is we can start to do other things with classes that are really ergonomic. So, maybe you want to have a unique ID for each class. We can do, let UID equals 1, and then each to-do gets an ID, which is the next unique identifier. We can have some methods, I don't know. You could do something like this, and then we'll add another button down here. I'm not sure why you would ever want to do this. But you can. And that's a really nice way to encapsulate logic in a way that works really beautifully with like IDEs and everything. Everything understands classes really well. And even to the point of if we were to log, in fact, if we were to inspect the to-do, then it's even labeled as a to-do in your dev tools, for example.
And that's because you're using a class.
Because we're using a class. Yeah, so classes often a little bit maligned in the JavaScript world for not particularly good reasons. Svelte really embraces classes as a way of describing the sorts of objects that you're interacting with in your app. But for day-to-day stuff, for like the simple stuff, then just using the state rune and throwing an object or an array into it is totally acceptable.
And I mean, when I first saw what you can do here, I thought, like, this is pretty crazy. You're just basically just declaring an array and then pushing to it, and your UI is updating. Like, that is wild.
Yeah.
Do you want to maybe just clean up the code a little bit, and then we can wrap it up?
So I'm going to get rid of these things that we don't need anymore, get rid of the count. We're not using that method, so we get rid of that. Get rid of the inspect rune, which is something that you can use during development to understand what's happening like inside your object.
Oh,
but
nice.
It gets stripped out for production. And then I'll get rid of the button, which we're no longer using.
So there it is, 32 lines, and we've got our classic to-do app working. That's awesome. Cool. Thanks so much for showing us how runes work. It's amazing. I mean, the whole idea is that they're magic, right? And I feel like in a few minutes, I've learned something incredibly powerful that is relatively simple to use. And I think, that's the effect you're going for. It's magical.
Yeah, it's an interesting word. Magic. A lot of developers have a pretty negative reaction to that. And we actually draw a distinction between magic and magical. The way that we use those words, magic describes something that is a little bit hard to understand. It's sort of, I don't know, it's a black box. Something is happening and you don't really understand why. And it makes a lot of developers feel a little bit uneasy. And I think Svelte in the past has been too magic. There's been too much stuff that is hard to understand. Magical, on the other hand, like you understand what's happening. Like they're all very clear mechanics that anyone who's interested can understand just by looking at the compiled output and looking at the code inside the Svelte library. But there's a lot of stuff that the compiler is doing on your behalf that you don't have to. As you're writing it, it feels magical because you need to do so little to express the ideas in your application. And having used it for the last few months, I personally really like it. And I think a lot of other developers will too. I know a lot of people look at that sort of thing and they're, I'm not sure. It seems skeptical. Like, give me explicit APIs instead of this. But I think once you've tried it, it becomes really addictive.
Awesome. Thanks so much for giving us a tour of runes. And I'm excited to see what people start building with it. If you're using Svelte 5 and using runes, please show us what you're working on. You can paste a link in the comments below. Thanks very much, Rich. Thanks for showing us around. And I hope we can have you back in the studio soon.
All right. Thank you.
So thanks so much for watching. If you want to let us know what you think about Svelte, or if you have any questions about anything we've talked about, leave a comment below or get at us on Twitter or on the Prismic forum. Otherwise, please be sure to subscribe because we've got lots more great Svelte content coming and we'd love to see you back here.